Hi, my name is Bob Tabor with LearnVisualStudio.net. In this video, I want to begin the process of dissecting that little application that we wrote in the previous lesson. I want to spend a few moments and take a look at every line of code in that module1.vb file and use that as the basis for further exploration in Visual Basic. So first of all, a quick review. In the previous video, we used the Visual Basic Express Edition IDE, which, as we noted, is identical, at least for our beginner purposes, to the Visual Studio IDE in order to create a new project called Hello World. Secondly, we wrote code in the area that was defined between two lines of code, that sub main and end sub lines of code. We then ran the application by clicking the Start Debugging button in the toolbar. And this opened up a Windows command line window, and after a moment our application appeared. The application simply displayed the words Hello World. Okay, so I hope you can see how your actions when building the application manifested themselves when running the application. But what I want to do is really cement these ideas in place in your mind because they provide the foundation for everything that comes next. So let's start from the inside and then work our way out. Let's start with the code that we wrote. First of all, we wrote code using a programming language called Visual Basic. There are many different programming languages in the world, but at this moment Visual Basic is one of 2 or 3 popular languages that are used to create .NET applications. Visual Basic is one of the main programming languages that Microsoft supports in Visual Studio. I'd highly recommend that you learn as much as you possibly can about Visual Basic in the coming days and weeks. Some consider Visual Basic your best choice as you're getting started. Most developers aspire to learn a programming language, one programming language, and master it as they're just getting started. But once you master a single programming language, learning a second and subsequent programming language will be easier because many of the concepts will transfer over even if the syntax is slightly different. As somebody who's been writing applications for over 15 years, I can assure you that Visual Basic is a great language to start with. My personal preference at this point in my career is C#, the other major programming language that's supported in Visual Studio. However, I started my career writing Visual Basic, so I've long regarded it as my bread and butter and a good old friend. Okay, so when you learn how to write applications with Visual Basic, learning the syntax of Visual Basic, in other words, the nouns and the verbs and the punctuation of the programming language, is just half the battle. The other half of the battle is learning about the related pre-built functionality that's available to the programming language. Now in our case, Microsoft created something called the .NET Framework, and while that sounds all mysterious, it's really not that bad. For right now, there's just 2 parts of the .NET Framework that concern us. First of all, there's the class library, which simply is a library of code that Microsoft wrote to take care of difficult tasks for us, those of us who are developers, so that we don't have to write every line of code to accomplish something by hand. So there's a library of code to help with math operations, with working with text, or displaying things to the computer screen, or transmitting information over the internet, and so on. The second part of the .NET Framework is called the runtime, also known as the Common Language Runtime, or just CLR. It's like a protective bubble that your application lives inside of. And what I mean by this is that when you write code, the .NET Framework makes your job a lot easier in the following ways. First of all, your code runs inside of the .NET Framework runtime, which is an application that wraps around your application. The runtime takes care of low-level details like managing how the data in your application is moved into and out of memory, and other similar functionality that prevents your application from accidentally crashing somebody's computer. It also allows your code to make use of a library of code written by Microsoft to take care of the low-level details like displaying data to the screen, moving data from one computer to another, working with dates and times, the down and dirty details of opening up files, reading and writing to them, and so on. So as a result, you, the programmer, get to focus on the important stuff, the real value or the purpose of your application. And again, for a reminder, this is called the .NET Framework Class Library, or the FCL. Some books refer to it as the base class library or the BCL. They're exactly the same. And I might even accidentally use those terms interchangeably myself. But either way, it's the exact same idea. So for right now, the .NET Framework class library is what I want to focus on. When we typed in the phrase console.writeLine, we were using some code in the library that knows how to display text into a Windows command line window. All we have to do is tell it what we want it to display, or rather the important stuff for our purposes. And we don't care how it writes the text, we just care that the text gets written to the screen displayed. Okay, so let's focus on the code that we actually wrote. When I wrote this code here in these 2 lines, I made sure to emphasize that the code that we wrote had to be in the correct spot. Otherwise, the application would encounter an error whenever you try to run it. The correct place was between the submain and the end sub. This style of sub, end sub defines a code block. Also, you can see there's a higher level code block defined that encloses our submain end sub, and that's called module. And so you have this module, module 1, with an end module at the very bottom, and you can see by the indentation layers the relationship between submain and the module 1. And so you can think of these code blocks as a series of containers. I'm going to oversimplify this just for a moment, and we'll build on these definitions a little bit later. But this innermost block of code has a name, and that name is main. That's the name of this code, and this code just so happens to be executed first whenever the application is launched. So let's not worry about those other words like sub and module and the like for now. This entire block of code defines a procedure, and a procedure is simply a named block of code. The main procedure lives within a module named Module 1. Modules have a special purpose in Visual Basic. For now, you can think of it simply as an organizational tool, a way to keep the procedures that you write organized and available throughout your application. Okay, so let's take a look at the first line of code that we actually typed in. Console.writeLine, open parenthesis, open quotation mark, hello world, close quotation mark, close parenthesis. So here we're actually executing a procedure, a name block of code that somebody else wrote. The procedure name is writeLine. And so this is how you execute the code that lives inside of a code block, by calling it by its name. In this case, its name is writeLine. That writeLine procedure lives inside of a code block called console. Console is the name of a class. A class is an organizational tool just like a module. In fact, module is a class that has special superpowers, and we'll get to that a little bit later. A class, at least at this point, simply defines a block of code that can contain other blocks of code, much like our module contains other blocks of code called procedures, in this case a subprocedure. So when we want to use the writeLine procedure, we have to tell the compiler which class, or in other words, which container to find that procedure inside of. So look for that procedure in a container called console, in a class named console. And then secondly, we wrote this line of code, console.readLine. So in this case, it's executing the readLine procedure, another named block of code that somebody else wrote. And both of these procedures, readLine and writeLine, are organized into the same class named console. Since both procedures deal with interacting with the Windows console, it just makes sense that they're both organized and that they live inside of the console class code block. Both of these methods have been written by somebody else, somebody at Microsoft. So we're borrowing code, or rather, we're executing code that was written by somebody else merely by referencing the name of the class that owns these procedures, in this case console, along with the name of the procedure itself. In other words, readLine or writeLine. And then there's a period separator between those names. The period is called a member accessor. In other words, we can access a member of the console class by using a period after the name of the class when typing the name of the member, or rather the method that we want to execute. So next, both the writeLine and the readLine methods have a pair of parentheses that immediately follow them. However, only the WriteLine method has a value inside of the opening and closing parentheses. The double quotes tell Visual Basic that we're passing in a literal string. In other words, we literally want those exact characters, those words, hello world, to be displayed. And you might say literal as opposed to what? Well, I'm going to answer that question a little bit later when we talk about variables. But the key idea here is that some methods can accept input values, such as a literal string in this case, hello world, which is then used by that WriteLine procedure to display to the console window in this case. We'll come back to the notion of procedures in the future. But just know that whenever you see the parentheses, think of procedure. Okay? So next, let's talk about the line breaks. You can see that everything kind of lives on its own line of code, and that was by intent. We didn't just willy-nilly separate things onto their own lines. In Visual Basic, you don't need to use a character at the end of a line of code to say this is a complete thought, much like you would in the English language with a period or an exclamation mark or a question mark. Instead, you just go to the next line. Okay, some programming languages like C# and JavaScript require you to add a semicolon at the very end of a line of code in order to tell the compiler that you're finished. Each statement of code then in C# and in JavaScript can live on its own line or can be broken up into multiple lines, but that's not the case with Visual Basic, at least most of the time. Okay, it is possible to take a single line, a single code thought, and break it up into multiple lines. We're going to do that more and more as our Visual Basic code becomes longer and more complex as a means of making it more readable. But generally, in Visual Basic, one complete thought belongs on one line of code, and you move to the next line of code to complete a second thought, and so on. Okay. So notice also the indentation of our code. That's completely optional, but it's so important that the IDE will add it by default. So why do you suppose that is? Doesn't it make it more readable? Most people tend to think so, and that's why it's enforced by the tool. Along those same lines, Visual Studio color codes the text that you type into the code window. Class names and modules are in this kind of aqua color. There's reserved words like module and sub and end. They are in a royal blue color. Literal strings are in this red color by default. You can change all of these colors, and we'll demonstrate how to do that in another video. But the intent here is to make the code more human readable, to see these distinctions between this type of code, like a literal string, versus a reserved keyword like sub and module and so on. Okay. So expanding out from this little code window area that we've been typing in, notice that we're working inside of a file called module1.vb. We see that as a tab here within the main area of the Visual Studio IDE. If we look over on the right-hand side, we see what's called the Solution Explorer. It has a tree-like view of several items. First of all, we see a project name called Hello World. And so this is the name of the project, and then below that we see a couple of icons, one called My Project, and this will contain properties for our project. So it's kind of a virtual folder or a virtual file, if you will. We'll come back to that a little bit later whenever we need to set different properties of our project. And then we have, thirdly, our module1.vb file, which is the code that we typed into. Simply put, the Solution Explorer is our main navigational device to the other files in the settings that, once compiled, will make up our finished .NET assembly that we can then execute or put on somebody else's computer. Files and important settings are organized into projects, which are then compiled into a single .NET assembly. We'll talk about that more later. Furthermore, one or more projects can be organized into solutions. Now, we don't see that in this case, but as we build more complex applications, you'll see the notion of a solution represented inside of the Solution Explorer. In many cases, as you're getting started, you're going to only have one project inside of a solution, but as you build more complex applications, it's highly likely that you're going to need to manage multiple projects that are somehow related. Again, the reason for that may not be so obvious right here at the start, but as you continue learning Visual Basic and continue building more complex business-oriented applications for large enterprises, this becomes a crucial code management strategy. But for now, just accept that this extra layer that you don't see here represented, called a solution that owns a project, is there for a reason, and it's important, but not until we move past some of these basics. All right, so the big question at this point is, or should be in your mind, where is all this stored on my hard drive? When you did everything manually before, you were able to dictate exactly where you wanted things to reside. In our case, we created this Hello World folder, and then we typed our .vb file inside of that folder, and when we created an executable, we created it inside that folder. But when you're creating things using the Visual Studio IDE, it will place things on your hard drive. When we hit the Save All button, it showed us where it was going to put it. So let's go there. Start off in your Windows Explorer in the Libraries Documents folder, and you'll see a Visual Studio 2010 subfolder. We'll double click into that. There will be a project subfolder, so double click into that, and here you can see the Hello World folder that we created inside of Visual Basic Express Edition. If we double click that folder, you'll notice that there is now a project file, so you can see that. It actually calls it a Visual Studio Solution, just like we referenced a little bit earlier. If I drill into the subfolder below that, here we see a Visual Basic project file. And so both the solution file and the project file are XML files that contain references to the files, like our module1.vb, as well as other settings for the project. If we were to open this up in Notepad, we could see all of the settings in an XML style format. I'm not going to do that, and I highly encourage you to, if you are going to take a look at that code, don't change it, because you will potentially destroy the settings in your project, and it won't be easily opened up then in Visual Studio or in the Express editions. All right, so below that, you can see there are several folders. For example, this bin folder, bin is short for the word binary. If we were to double click that, there are two folders beneath that. There is a debug folder and a release folder. So whenever we hit the run button, the start debugging button on our toolbar, it created a debug version of our application, an assembly called hello world.exe. Now we don't see the file extension here because in Windows Explorer we have that hidden due to our preferences. However, there are also some other files as well, this PDB file, this VSHost file, and these are there to allow for the debugging of the application. We'll demonstrate that in another video. We could double click on this and see our Hello World application executing. The other folder is the release folder. Once we have finished debugging our application, we may want to create a version that we can actually install on somebody else's computer. When we choose, for example, right now there's nothing in this folder. If we were to choose debug build hello world, this will create a different version of the executable that's optimized for executing on another person's computer. So it'll leave out some of the debugging information that was built into the debug version. So in this case, we see now we have a in our release folder, we have a hello world.exe application. I can execute it. It still has some of these extra files, but we could delete those, and the application would still run. Okay. All right, so it probably makes sense to stop there for now. In this lesson, we covered a lot of ground, so let's just briefly recap. We talked about the code that we wrote in the previous lesson. First, we talked about the organization of the code, how the code is organized inside of the submain end sub, which represents a block of code, a code block. We added code to a method, or rather a procedure called main. So our code block had a name called main, and that main is a special name that is automatically executed whenever the program is launched. We talked about other organizational containers like the module being a type of class. We used classes and procedures that other people have created These are contained within a library of code called the .NET Framework Class Library, the FCL, or the Base Class Library, BCL. When we wrote our code, we passed in an argument to a procedure. Now, we haven't used that method ourselves or that technique ourselves, but we were able to pass in information into a procedure. That procedure then used the information we passed in to then render those words, hello world, to the screen. Now, we don't care how the write line procedure works its magic. We just care that it just knows how to display that information into a console window, whatever we told it to do. We talked about the syntax of Visual Basic, specifically the need for writing each line of code on a separate line and not use any end of line or end of thought punctuation. We talked about spacing and indentation, how these don't affect the code, but they make it easier for those of us who are human looking at the code as opposed to the compiler to actually read it and understand. We also noted how the IDE's code editor uses color to further assist in the readability of the code that we write. We talked about the Solution Explorer to understand the organization of the code. We talked about projects as a means of collecting all the files and the settings that are required to create a compiled .NET assembly. And we briefly explained how multiple projects can be managed under a single umbrella of a solution. Finally, we talked about where you can find all of the files for your project, as well as the file structure for the compiled versions of the debug and the release versions of our .NET assembly. And we'll look at debugging applications and what that really means in another video. So the good news is that you're well on your way to learning .NET at this point. Some of the more tedious aspects are already behind you, and it just gets more exciting from here. So next up, we're going to review the basic features of the Visual Studio IDE that we've been using, and then on to learning more about expressing the logic behind our programs using the Visual Basic syntax. So we'll see more in the next video. See you there. Thank you.